everybody, welcome back. So we are still writing our FIX SBE Binance connector. So last time we've connected to Binance, setting up the transport to testnet, and today we are going to keep moving. So let me walk you through things I've done that I thought are quite low value added. So I just went ahead and did those. So if you remember last time, we've just written a simple struct that could encode a message into the buffer, the output buffer, the writer. Well, that's gone now. And I've replaced that with, so I took the XML from Binance, exactly, just downloaded that. And I've written a code gen here that basically, so if I go to main, so using libxml2, because I couldn't be bothered to write my own XML parser, I read the file to parse a schema here. And then I use the schema to generate files. So let me just walk you through what I'm doing here. So I parse, so these built-ins here are types that are defined in the SBE documentation, but not in the ZIG, or rather the Binance file. So those would be your U8s, U16s, and stuff like that, right? So just map those to the ZIG types. Then we have the types, which are the types in this guy here. So in this field type between these two tags are the types. So I get the child with type or with the name types, and then I just go through each of the children, and if it's a type like this, so that those would be type aliases. So can we, there we go. So something like this. These are basic type aliases. So Mantissa64 is basically a UN or an I64. Same here for exponent 8, that's an I8. So those are just type alias and stuff. So I just create this, or I add these types to the schema here with kind alias. Same here for enum types. So can I, yeah, there we go. So here we have enums. So same goes there. And then I go for all the composite types. So these are the complex types that we have that basically are containers for other types. So if I take an example of these, that would be something like, let me take a complicated example. So this one here, this has a block length, which is a U16, and then a number in group, which is also a U16. And we can have, for example, strings are this composite here, which has a length, and then a what basically is a U8 slice of this length here. And of course, these are UTF-8 characters. So yeah, we go through all of those, get the get their fields, and we do a few things here. If they have like a length, I group, or I type those as data. If they have block length, I type them as group dimensions, and otherwise they're just composites. Beyond this, I also parse the messages, which are the main unit of information exchanged between us and the exchange. So those would be just after the types. So yeah, so here just after the types we have different messages, and messages have can have 3 different type of let's say members. They can have fields, which are just basic I'd say, primitive data types. They can have data which are usually row data types. So these are like U8 slices with some sort of length attached. And then we can have groups. So those are something like this. And groups are basically repeating sets of whatever is in the group. So however the group is defined. So here we can have miscellaneous fees, which is a group. And then we can have n miscellaneous fees defined by the exponent, the fee amount, the fee type, and fee currency repeating. So yeah, those are also handled in this guy here, passes the field, and if the field is a group. So basically just very tedious string interpolation and parsing. All of this gives us, so if I go back to main, a schema. So this guy here, which is just array list of types, basically. And then we go from this schema to write the generated file. And this guy here will be just a basic zig file that contains, well, all the declarations. So we are going to create zig enums, zig type aliases and stuff like that for each of the types that we have, or each of the declarations that we have. Then we are going to emit types as zig structs. So those just look like something like this. And then we are going to emit containers. So basically containers are anything that has fields inside. So those would be groups, messages, stuff like that. So just go ahead and emit those. I'll show you an example of the generate file in a bit. And then we are going to emit messages. So those would be like structs containing the message items and stuff like that. And then there's some sort of generic functions here to dump the messages and stuff like that. So these call into this SBE module here that I've also written, which is imported from this guy. So let's actually take a look at that SBE module. So this guy here just has a few functions that are useful to read from a buffer. So just knowing the kind of primitive, we can decide how to read it from the buffer. So we are just going to do memory reads. Same goes for memory writes. We have some other things to write to the primitive directly in buffer. So those are basically what we have. Same here for containers. We just go through so basically let's take a look at something like our logon message, which should be somewhere over here. So logon. So this would be a container, and it will have these fields plus these data here. So if we go here, write container takes the schema, the container, and the so the container to write and the body to write it to, and it will just go through all of the fields and serialize them. Same for data and same for groups if they exist. So I guess that's pretty much all for these helper functions. If we take a look at, so what's the most important part of this, I would say that would be something like this guy. Yep, this is the most important part. So typed API. So this is a struct that basically has, it's an encoder decoder. So I just call it a codec. And it basically is a helper struct that has a lot of functions that basically make it easy to serialize the fields for each of the types. So here, for example, for each of the types, we are going to emit one function that's so something like if we have a field foo, we are going to have a function foo that reads the field, and a function set foo that will try to write to the field. So there's one very important caveat here that I need to mention. Since we are working on SBE and I'm trying to make this not allocate, so this is very much in place serialization, or just forward serialization only. There's no look back. What happens is that we are obliged to write the fields in order, or rather in the orders they appear at, and we cannot just use offsets because, for example, here sender comp ID is a var string, so that means that it has a variable length. So there's no way we can, although we can compute for all of these fields their offsets because these are known types of known lengths and fixed lengths to add to that. These fields here, so sender comp time, target comp ID, and row data and username, are all variable length fields. So there's no way we can actually know where to write target comp if we don't have sender comp ID already serialized. So serialization uses a sort of cursor style serialization to know where we are writing to, and that means that we are obliged to write fields in the order they appear as. If the field is optional, so like something like this, there's logic in the generated code to basically just skip all the way to the next offset. But it's very basic, so yeah, that's the main caveat. Same goes for groups, because groups are just data, but more hardcore, because we need to have so we have a sort of header in the serialized message that gives us the group dimensions, which is these guys here. So if I go all the way here, so this is the group header. So we need a U16, so basically 2 U8s, to encode the group size. And then for each of the fields, we need to know where that goes into the group, and then the group can have multiple fields, and it can have nested groups. So you can see where the problem lies. So that's why very important to note that caveat. So let me just go ahead and open an example of what the generation looks like. So it's a very long file. It's I believe over 6,000 lines. Yeah, so 6,200. But it's all just repeating stuff. So if we look for logon, no, actually, let me go through some of these. So all the type places are generated here. Then we generate the enums. Then we generate so some helper slices or arrays here. So these are all the types with some metadata on those. And the containers. So the containers are basically, as I said before, just anything that contains other fields. So those would be groups, messages, and stuff like that. So anything that contains anything is a container. And here we have fields. So fields are basically just a flat array of all the fields defined anywhere in the XML file. So it's just a flat array. And what I did is just concatenate all the fields for every single message. So if we go up here, so this guy here is test request ID. And if I go here and do test request ID, can see that it's on the very first message here. I have this field here, ID 112, test request ID, and then so test request also has that test request ID. So if I go back here, so you can see that that guy is done twice because because the type is different. So I guess that's why it's being output twice. Yeah, and we can see that in type index. That's different. Right, so here it's basically a flat list, flat array of all the types possible. And we can have, just after this, we are going to have the messages, or rather the templates, IDs, of course. But here we have messages, and messages are defined from their template ID and their container index. So basically, this heartbeat here is container index 0. So if we go to containers, so containers, there we go. So this guy here is the metadata for that heartbeat field. So messages, there we go. So just after messages, we are going to also get, so no, I think that would be in containers. Yeah, so containers are basically define the first field from the fields list, and how many fields from the first field we are going to take to define the container. So let's go for this guy here, news. If we go to the XML, look for news, you can see that it's a container, it's a message that has just one field data here. And if we go back here, you can see that its first field is 333 and field count is 1. So if we go to fields and go all the way down here, so you can see that this guy here is the only field that's in news. So it's called headline. And let me check, is it correct? It is correct. So that's how this parser works. And then we can get to the actual stuff we are going to use. So what we are going to do is create these kind of codec objects. And these guys we can create on the fly because the main functions here to create those are just this encode and decode functions, and those take in a buffer. There's absolutely no allocation going on in here at any point. So yeah. Difference between decode and encode, they create both the same object. They just change this mode here for a bit of safety. Because for when reading the messages, we need guarantees that the message is immutable. So that is basically what we are doing here. So when this mode here is decode, and we try to, so there's this here, ensure immutable, or ensure mutable. Whenever we try to write to the message, we call that just to make sure that we are not writing to something we are reading from elsewhere. So that's pretty much all there is to it. And the difference also is decode starts from a known body length, so it can be efficient about computing the offsets and stuff like that. Whereas encode starts from a fresh buffer, so we are going to overwrite the buffer. This lets us reuse the same buffer to encode multiple messages if needed. So for the actual parts that are interesting here, we can see that, as I said before, if we have fields foo, we can have function foo. So this guy here, the field is test request ID. So we have function test request ID and then set test request ID. So basically does what it says on the thing. And if we go to something like logon, which is what we were interested in last time, so we have a few more functions here. So encrypt method, set encrypt method, heartbeat, sequence number, message handling, stuff like that. So what else do I need to say? Yeah, so optional types are passed as nullable, as options. So we can just pass in null and it will choose the correct null value for the given type. So that's very cool. And I guess that's all there is to it. So let's go to our main. So this is the new logon message using the logon codec, and you can see that it's a lot easier to use than what we did before. This for logon, I have this sign function here. That's very specific to it. That computes the raw data directly and puts it in the message. Very nice, very simple to use. So these guys here haven't changed. The only thing that changed is now we have this FIX transport that basically reads the next message by looking at the open framing header, then deciding, looks at the open framing header, parses the message from the frame, and then consumes the message or returns the message as a body from the reader's buffer. So basically that's all we are doing. We are just going through the reader and taking its buffer and returning a body, which is the buffer. And that means that now we have this frame message and we can, for example, we have this dump message here that basically switches on the type from the message. So it goes through all messages, compares template IDs, casts our message, rather the cast should happen somewhere here. So casts the buffer into whatever message container schema that we have, and then just writes each of the fields from that. This is just for basic debugging. So the way it works is so zig build and zig out bin fixed. There we go. So the way it works is just this. It outputs this sort of thing here for each of the fields we receive. So this is for the logon ACK message. It will use the schema to know how to go ahead and parse all of the fields. So now we can see that we have connected and we got a UID. So yeah, very, very good. I think it's very nice to use. What we can do is, for example, we can go ahead here and do something like, so this buffer here we can reuse. So we can just go ahead and do, so const, let's do logout, I guess. Yeah, let's just log out. So log out codec is binance.logout codec dot init, or no, dot encode. And then this guy takes any buffer, so this one be just message buffer. This does not fail. And I guess we are going to need the message header also, so let's just make this a variable. So this guy will need to be a variable. So I'm just going to, yeah, I guess that would be fine. So let's do var message, no, it's already fine. Message header is binance.logout codec. So I added also these helper functions here, message header that takes in sequence number. So sequence number, I think we are obliged to increment this guy. So sequence, can I please do this? Sequence number plus equals 1. So this guy takes in sequence number and sending time, which would be, so let's do this? Yeah, sure. This guy here will become at endcast because this guy wants a U64. So this would be now 2 microseconds. Okay. And now we are going to need to use log out codec.set text. There's just a simple text value here that we need to set. I'm just going to set it to something like by. Of course, this guy needs to be tried. This can fail, of course. And we can go ahead and, you know what, let me just do this and copy all of these. There we go. So FIX transport writer takes in the message header. This guy would become logout codec encode body, and this guy would be log out. Okay, I think that should pretty much do it. So let's build this again. See, there we go. So very nice. So we sent our logout. We got our log out acknowledgement back from the server, and we are done. The connection was correctly closed. Very nice. So now what we need to do is actually take this one step further, because we want to, if we go back to our goals, we want to create a market data session, or rather, yeah, let's start with market data session. But we first want to get the instrument info from Binance. So let's get started on this. So how do we go about this? So what we need is a message bump that's going to handle a few things. So first, we need to establish a last-in session. The current session is not last-in because what is going to happen is, so let me just remove all I added here for this guy, and I'm just going to do this. And of course, these guys just need to become const again. So here's what's going to happen. So in 5 seconds, there we go. So here we get our heartbeat. We get our test request to send a heartbeat. We're not sending it, and we get killed because we are unresponsive. So we need to create a last-in session. So that means that we are going to also need to establish a heartbeat with the server, and the heartbeat goes both ways. So we need to send our heartbeat on a timer, and we need to check when we receive a message, if it's a heartbeat from the server, that it's not been too long since we've received the heartbeat. Otherwise, that means that there are issues on the link. Right, so how do we go about this? Let's create a session. So this would just be a struct, I'd say. Sure. Whoops. So this struct here will have, so maybe we are going to start with the functions first. Let's start with the operations here. We need to initialize a session. So the session will handle all of these things here. So creating the TLS connection, doing the first handshake. So the logon stuff is going to be done on the session start, and it's going to need to start this sort of message bump here that waits for the next message and then does something from that. So not sure how we are going to do that just yet, but let's start by doing it, I guess. This guy here will need to, so we either pass in the transport, Actually, that might be a good idea. So here in connect, is there like a world where instead of passing in the arena, we could pass it self as a transport pointer, and this guy just does nothing, just does void. And we can do this. That means that now in, so if I go back to main, I can do something like const transport is arena.create. So tls.transport. And this guy, yeah, so I guess we can do something like this, and we can do transport.connect. Yes, of course, this guy needs to be, this guy needs to be tried. Does this still work? So I'm just going to try this for a bit. Okay, it does not work because, of course, this guy should not return anything at this point. Okay, still does work. Cool. So this will allow me now to... actually, can we not do... Now that we have this this guy, can we not just do something like undefined? And yes, sure. And then we can do something like, well, this guy will now need to be var. Does this fail somehow? Okay, so we got rid of all the allocations that we had. So now what we can do is we can just pass this guy here. Yeah, you know what? I'm going to keep the allocation actually, because I want to force transport to be passed as a pointer. I don't want it to ever be copied because that's a world of hurt. Right. So okay, fine. So this guy here is going to get an established session. So this guy will get a transport. Do we do that? No. This guy is going to get an arena. It's going to create a transport. So statmem allocator. No, but in this case, there's no need to do that. So transport is tls.transport. Okay, I'm going to make up my mind at this point. So const self. So this guy here needs to be undefined. And this guy here just needs to return a session with some data here. And then we are going to get public function connect. This guy here will take in self as a pointer to session. So we can embed transport inside session without having it to be, or without having it being a pointer. We can do this guy. And that's all we need, I think. No, there's a few things more we need. We need IO, which is state IO. Actually, cool, I've already done that. So now I can just do something like this, which is very good. And then we are going to pass in, what else do we need? I guess the host name. Yeah, we need the host name. So that would be, so host or URL would be just a constituent of this guy. This guy can fail, but doesn't return anything. And this guy here does self.transport is dot connect to using IO and URL. Try. Okay. And then I guess we are going to now start using the message bump, or we can first just go on and create a message buffer in here. So message buffer. Do we actually need the message buffer? Can we just write to... oh, no, we cannot write to the output socket directly because we need to write the open frame and header first and the message header second. So yeah, we are going to need an outgoing, so transmit message buffer, which would be, let's just go for something that's big enough for all future users. And I'm just going to create that as undefined also because I don't care. Right, so we're just going to go ahead and create. How do we go about this? I am going to get this guy. Right. This guy here becomes self.tx, I guess, message buffer. Right, so this guy here also needs a key pair. So that's crypto.sign.edwards255.key pair. And it needs a sequence number. So I guess we are going to need to manage sequence numbers here. So sequence number would be some sort of stud. Do we just... yeah, let's go for atomic's value. This would be... so hold on, what is this sequence number? U32. So let's just create U32 over this. And this guy is initialized to 0 so that we can always do the thing like this. So self.signum.fetch add. And then this guy will take 1, and monotonic is... we don't really need much of... yeah, we don't really need much in terms of, I guess, syncing on this here, or ordering on this. We don't need strong ordering. We just need the number to be monotonic. Actually, just going to initialize it to... I'm not sure if 0 is a bad number. We're going to see. So here we get the now. Actually, this sub duration here is kind of pissing me off. So let me just add options. This would be options, and this guy here would have sort of like pop-const. Options would be a struct that will have so clock rewind. This would be a std IO. I guess we can do just IO. Duration, sure, which is from microseconds 0 by default. And I guess this guy is not used, so okay, so this guy here becomes options, well, options.clock rewind. Fine. That looks very good. So now we need to wait for well, we need to do these guys. So let's do all of this in here. This is done once, so we can actually do it like this. It's not going to cause problems. And of course, we need the message header. So const message header. Let's just call it msg header. So this guy here would be binance.logon codec.message header takes in self. Ooh, so this might be problematic. So let's get a const sequence. Yeah, sure, sequence number. We can do this. This would be self dot signum dot fetch add one and monotonic. Sure, and we can just go ahead and do signum here, as well as here, so signum. And sending time is, of course, now. I might change this to, yeah, I'll add to do note for myself, change the codegen so that message header takes a IO timestamp instead. Yeah. So, but in this case, I'm just going to intcast this guy. So this would be now 2 microseconds, and that should be fine. Right, so this guy is message header. And then here we need to do self.transport.flush. Just so that we send that. Right, we also need to get at least one message from the server, and so this guy is self. We don't need this guy anymore. Actually, I think we do. We do need that guy, and I think we're also going to add this guy here. So I guess here we should not see any errors. So what I'm going to do is just try on this guy. Yep. And then here, just going to, we need a writer. So can we just do something like, where is the, sure. No, never mind. We can actually do something like, so framed dot, I don't really want to just dump this. What I'm going to need to do though is check, so log on ACK codec here. So to decode this guy, so just before I decode this guy, I'm going to need to basically get the message type. So that would be this guy here. So that would be header.template ID. So I guess I could just yeah, let's throw this away and do framed const template ID is framed dot header dot template ID. We are going to if so binance dot logon ACK codec dot template ID is different from template ID. We are going to return error dot logon not act something like this. Otherwise, we are going to try to decode this guy as a so log on ACK decoder, or rather no, codec is actually I should probably just call them yeah, I am going to rename this to encoder, because just so I know in what capacity this is working. So decoder, so this guy here be binance dot logon this guy dot decode, and this guy will take in framed dot body, which is a slice of U8 that we are going to work on. And now we are going to just go ahead and probably log dot debug got a log on ACK with I guess the following thing, which is log on ACK decoder, decoder dot get or dot UID. And I just realized that UID, since I constructed Zig style names by making them like camel case, the first U is lowercase, which is funny. Okay, cool. So now let's start by trying this out. I'm going to get rid of the set out buffer. I'm going to get rid of all of these guys and the message pump. Yeah, I am just going to do const session is so this guy is session. This is init, takes in nothing, absolutely nothing. So now we are going to try session dot connect that takes in IO MD host key pair, sure, and options clock rewind, and this from seconds, I guess, seconds, and we set that to 3 before. And let's see, does this build at least? No, it does not. So expected main, okay, so that's, whoops, that's a fairly easy fix. Invalid string format, of course, because this guy here is not a string. This guy is this. There we go. Ooh, so we've reached the end of stream. Wait, hold on. Why did we establish 2 TLS connection? Oh, I see. I see. Okay. Can we just do this, maybe? Just want to see what happens next. So maybe we should, yeah, let's think about the message pump first. Okay, let's do this. Function handle, let's call it session loop or something that takes in self, pointer to session, and that's all. I think this should not error out. I think. I'm not sure. Well, we're gonna see. We're gonna see. So in this guy here, we are going to receive messages. So we are going to need to have a while true, while self dot running, I guess, kind of thing. So let's do something like running is bool, and that's set to false by default. And then here at some point, we are going to do self.running is true, and start the loop. Okay, fine. So I guess we are going to do something like this in a loop. Just get a message and get the template ID. And how do you go about this? We need to switch on this template ID, I think. So switch on template ID. So let's start by else at panic. Let's not panic. Let's not panic just yet. Let's just debug and received unhandled message. Where it's something like this. And can we do something like actually yeah, okay, I have a pretty good idea of how to do this. So this guy here needs to become this. We need a const dump buffer, which would be something like this, u8 undefined, and we are going to create a const writer, which would be io.writer fixed, I guess, which would take dump buffer. There we go. Very cool. So this guy here will take so fix transport.dump. What is it called? Write message? No. Where the hell did I put that guy? So that should be in fix session dump message. Okay, so it's not fix transport, it's fix session that I called that. Okay, so yeah, I guess fix session dot dump message, and then this guy takes in a writer, so this would be writer, and the framed message to that would be framed. And then we can just go ahead and do this and writer dot or yeah, sure, writer dot buffered. Something like this, right? And we continue, I guess. So otherwise, if the message is so fix or no binance dot logon ac codec dot template ID, then we not sure what we are going to do, but we are going to do it. We are going to do this. Yeah. Okay. So that's the loop. So now let's actually start the loop. How are we going to start the loop? I kind of want to do something like session loop, and here use io.future. This guy has no type. Let's undefine this. I'm not sure how to do this, but self dot session loop is equal to io dot async So this guy takes in a function, so that would be session loop, and some arguments which are going to be just self, I think. And I want to believe that this guy is just going to get the, or start the loop immediately. So let's also do something like disconnect, takes in self, of course, session void. Can this error? Not sure. And here we are going to try self.session loop.cancel. Yes. Takes in IO. So I guess we need to store IO, or do we just get IO? Yeah, let's just get IO. And we need to also set self.run into false. Sure, I'll try to write that. Well, I don't know. Let's try it. Expect 3 arguments found to, of course, there's an IO that's been lost inside this guy. So this guy needs IO function and args. Incompatible types, fix, message, framed, and void. Of course. So I'm just going to do something like this. And then this guy here now becomes try. And then, yeah, I think we just need to do this. And here we just need to, I don't know. I do not know. Just try this. But this is, So expected type future of thing, but found. Right. So this guy here, can we do something like, do we need to do any error, or can we just expected U8 found a pointer to const k. So that should be around our message here. So this guy needs to become a variable. What now? Okay, this guy also needs to become a variable. See? Error union is ignored in the message, of course. Let's not do that. Expected type, but found. Okay, so can we do something like this? No, it's not. It's not the thing. So any error, can this be defined like this? Ooh, okay, so I guess. Wait, what? Yeah, of course. We need to defer session.disconnect to free the thingies. Expect one argument. What? Oh, yeah, IO. It expects IO. And of course, it expects this. Okay, yep, that's true. So catch. Yeah. Okay, so we are still. The loop is still not looping for some reason. Not sure why we just get So let's do something here. Catch unreachable. Let's just see why this guy fails. Okay, so now this guy here just dies because we ignore the error. Sure, and then we can do log dot error died, and some sort of thing like this with E. Yeah, I'm not sure what this is doing. Can we just log .debug got framed something like this framed. So wait, hold on a minute. Oh, okay. I see what the problem is. I see what the problem might be. So let me just do something like try session dot session loop dot await with IO. We need to block this program where it's programming. Okay, fine. So now we are getting the thingies we want. Right, so let's take a look at what this problem is. So we get an end of stream while we're trying to read the start of thing off of the transport. So, okay, let's actually go here. So this is where we are dying, right? So let's log debug. Of course, we need const log is set log scoped, and this is fix transport. Right. So this guy TCP received is, let's do something like this with reader.buffered. Sure. Okay, so we are not receiving anything. Hold on, are we correctly sending the message first? Self.transport.flush. We are writing the logon encoder to that guy. We are flushing this guy. So can we maybe just do send logon and do something like this guy, and do writer.buffered just to know what we exactly sent. And I'm going to also, I'm just going to do this because at this point I just want to know the actual message. Okay, so for some reason we are getting end of stream, although we are sending the correct thing. Well, this is embarrassing because this is one of those periodic reminders to read the friendly manual or go friend yourself, because I said we are going to set the signum to 0 and C, and I think that's what caused the problem, because if I do this, so we're not getting anything back. If I do this though, well, we are getting something back. So what have I broken again? Oh yes, of course. So stat out writer.flush is what's needed here. Let's try again. There we go. So now we do get our thing back. So let me put this guy away and hopefully just do this. Actually, no, now that we did this, I'm tempted to move the logon ACK handling into connect. But first, let's see that this works. Memory leaked. What is going on here? Why is there a leak? Is it because yep, there we go. So this guy here. There we go. So now we do get framed, and we got an logon ACK. Then we get our message for the heartbeat. But our message pump is running. But what I want to do here is now I'm going to bring back the ACK handling inline, just so that we know that we are correctly connected to the session. Right, so let's go for const framed is fix transport dot. Yeah, let's just block for the next message. This would be self.transport dot TCP TLS client dot reader. Okay, and this guy here can error out, but for now I'm just going to ignore that. Right, and here I'm going to check that framed dot header dot template ID if this guy is different to so I guess binance dot logon ACK codec dot template ID, we return error logon not ACKed. Otherwise, so at this point we should just consider that we are logged on. I don't think we need the UID, the logon UID at any point. But we are going to at least print it. Yeah. So how do we go about this? We should create a logon ACK decoder that will then be a binance nans.logon ACK codec.decode from framed message.body, and then const UID will be logon ACK decoder dot UID. And of course, this guy will need to be tried, of course. And let's just do log info logged on successfully, and something like this UID. Right. Can we? Cool. So we have logged on successfully. So now we can actually go ahead in our session loop and just drop this guy. Right. So now what we need to do is we need to handle. So if I go all the way up here, there are two types of messages. There are administrative messages and there are application messages. So let's first handle the administrative messages. So first, the heartbeat. So this guy here is sent by the server periodically, so that we know that we are still connected. And then it's sent by the client to indicate that the session is still healthy to the server. So it's also sent by the client or the server in response to a test request. That means that when we receive a test request, we need to respond back with a heartbeat. So I guess that's the first thing we need to work on. So first, let's do if this template ID is, I'm just going to do this here, is binance dot, what was that? Heartbeat codec dot template ID. And then we are going to, so what do we need to know here? Heartbeat has a test request ID. So which is not required, but if we send a test request to the server, we should expect to see whatever we sent in there here. Otherwise, I am just going to do something like self dot last heartbeat timestamp is, let's go for IO timestamp .now. Do we have an IO? We do not. So we need an IO in here. And this will be just a real-time clock. We also need to actually go up to here and add. So this guy here is for the loop, and here we are going to add a section for heartbeats. So heartbeat timestamp is IO timestamp. I guess that's pretty much it. So this guy is last heartbeat timestamp. I'm going to also add last. So thinking here, last test request timestamp, which will also be a timestamp. Hopefully, yeah, let's put this as option or timestamp. So the logic I want to implement is I'm going to have a timer, so timer, that will trigger every this number of seconds here, which we could export to here. Heartbeat interval, which should be an IO duration, I guess. And then this is from seconds, and we'll set it to 30 for now, which is okay. So options dot heartbeat interval, but this one wants an in, so 2 seconds. It wants a U32, so I guess I'm going to int cast this guy. Right. So that's that. So every heartbeat interval seconds, we are going to check if we received a heartbeat. Or rather, once we receive a heartbeat, we are going to check if the number of seconds has elapsed. If the timer goes off and we haven't received a heartbeat within that time, we are going to send a test request to the server to get back a heartbeat. And this here would be to indicate that we have sent a test request. So that's for this. Now, if we, yeah, so that, I guess that's all I want to do for this. What's the next thing? Test request. So if we get a test request, so binance dot test request codec dot template ID. So this guy here will What we are going to do is, so we have test request here. We need to just send back a heartbeat. So this would be const heartbeat encoder is so binance.heartbeat codec.encode, and this will be self. This is going to be problematic because we need to synchronize who's writing to TX message buffer, or we can just not have a TX buffer. This is, yeah, let's not have a TX buffer. Let's just stack allocate a buffer and get rid of that once we are done. So where is that used? That's used in here. So let's do var TX message buffer is, let's just call it message buffer for now, is of course, not sure how much I've allocated before, but let's do this. U8 is undefined because we don't really need it to be defined. And this guy is message buffer for now. So now let's also get this into session here. And you know what, since in the session this is single threaded, we can actually just have one single reusable message buffer up in here. And we can do message buffer. So we are going to encode into that message buffer. We are going to get heartbeat encoder.set test request ID. But before we do that, we also need to get test request decoder, which would be a Binance test request codec.decode. And this guy here will have framed .body. Yes, of course. So now we just need to pass this to that. So test request decoder test request ID. This guy reads it. This guy sends it back. This needs to be tried, and this needs to also be tried. Okay. And of course, this is not done just yet. We need to also get this guy. So thinking, yeah, we need to get this guy. And then we need to also get, yeah, the message header, and then we need to flush this guy down. Right, so this is how we are going to do this. So message header goes there. This guy here needs a now. So I guess const now is io.timestamp.now from io and from the real-time clock. And I guess we should always skew it. Yeah, we should always skew it with the options. That's kind of disgusting, but no, actually, you know what? I'm going to try to not do that and just hope for the best. Right, so this guy is heartbeat encoder, please. Yeah, encoded body. Right, so this send, I'm not sure what this is saying, send heartbeat. I don't really need to know what it sent as long as the message is gone. This guy can go, and we have a flush, we do. Cool, so that's it for the heartbeat. So I think now we can at least test this out, because we are going to wait for 5 seconds, get a... so last heartbeat timestamp, this guy should also be this, and we'll set it as null for now. Missing tuple, of course. Where did we define our thing here? So this guy takes in also IO. So expected, right, 137. No, 137. This guy needs to be variable. Okay, so we are going to wait 5 seconds. We should get the test request and we should send it back, set back a heartbeat. Wait, did I put that to 30 seconds? Okay, maybe I'm going to put this down to just 5 seconds. Wait, why is that? Actually, there's one more thing I need to add here. So if framed dot header dot template ID is binance dot reject codec dot template ID. So if we get any rejection message, we should return error dot rejected. And here we should how to go about this. So I would love it if we could just do something like this guy and get a writer from the log thing, but it's not available. So what we are going to need is a stud debug dot writer. No, there's no. So is there like a writer here? No. Okay. All right. Let's just get the reject message. So this would be const. Yeah, just const. Reject decoder, and this guy would be Binance. So we know how this works by now. So dot decode from framed dot body, and then here we can go reject decoder dot text. Yeah, text. This should be the error, and we can go error received error from Binance. Let's just do something like this. This would be this would be this guy, and this would be try, and this would need to be this. Okay. Ooh, hold on. First, let's do this, and now let's do. So what was the issue here? This text here could be nullable, be optional. So let's do something like this. Okay, so this time we've logged on successfully, and we sent back a heartbeat, and we received a reject. Wait. Hold on a minute. What is going on? So hold on. We got the framed message here. So where do we got framed? So that's here. I think we just don't care about this anymore. We are going to go down this unhandled message route here if we ever get one that we did not handle. So here we are getting the log. Right, so this guy send heartbeat. Oh, I see. I think I see what I did. This message header here is not correct. Okay, so heart beat codec. Okay, that should do the trick because I didn't understand why they were talking about log on message. Okay, so now we are getting a reject because this time the timestamp was 1 second ahead of the server's time for some reason. So I'm going to need to options here. I'm going to somewhere do clock rewind, and this guy will be io.duration. I'm just going to initialize this guy from the options. I don't know. I do not know. So for now, this is getting very ugly, but let's move. So clock rewind is options dot clock rewind, of course, and we are going to need to go down here. So where did we get our, so this guy, so sub duration, and this guy will be self dot clock rewind. Of course. So 5 seconds. And we sent a heartbeat, and we are still alive. So we have a session that's still running. Okay, cool. You know what? That looks very good. What we should do though is we should avoid having the server send us test requests. What we should do is we should send heartbeats on a timer. And to do that, we are going to we are going to need to make this session loop, not a session loop. We should make this session like a future. And what we are going to do here is try to use a new thing, a thing in IO, which is the select thingy. So let's call this select. This would be io.select. I think it's like this, and this guy takes in a union or something. No, it takes in a type, so this guy would need to be a union that has well, I'm not sure. So let's call this select type. Or maybe I should. Yeah, that's fine. That's fine. So this guy here will have either a heartbeat timer, right? This will be will just return void, or we can have the session loop, which returns, I think, any error or void. Is that right? Yes. So now we can do is const select. That would be select type dot init. Takes a union, a buffer of union of whatever the type we've sent. So this guy heartbeat interval. This will be a let's go heartbeat, or let's do handle heartbeat, and the session loop. This would be session loop, right? Yeah, I guess this guy here will need to become this guy. And we are going to also do handle heartbeat function handle heartbeat that will just take in self as a session. And probably even IO, I think, that will just return void. So for now, we are just going to do log.info timer fired. And actually, no. Actually, no, because, no. So I'm gonna need to go into this guy and see. So we need a buffer of these guys. Okay, I see what the problem is. So this guy here, just going to create a buffer like this. So const select buffer. So this guy will be this over, and I guess I'm going to need to do this. Yeah, so const select union is this. So this guy will be, so I guess we can get rid of this and just do IO select of select union, and this guy will be select union. Let's just do something like this and define for now. Select buffer union. Right. Okay. We're getting somewhere. We are starting to. So this guy is select, and now instead of passing in IO, we want to pass in session loop for this field. And hold on a minute. Do we need to? So this guy is void. So now, hold on 1 second. This guy is void, so I can do something like this. Just get this in here. Cool. Very nice. This is what I wanted to do. This guy, does it need to be tried? No, I don't think so. I don't think so, but now let's do async. And we want heartbeat timer. So this guy here, this function needs to be so std.io.sleep. Hold on. I'm kind of missing something. Right, so this guy, let's do something like this. This guy needs self. No, it doesn't need self. What does sleep need? It needs an IO and a duration and a clock. So IO duration would be self.heartbeat options, not open file, options.heartbeat interval. This is a duration, I think. And clock is just awake. Yeah, let's go for the monotonic clock, because we don't really need to have anything else. So select dot I guess that's it. But how do we call handle heartbeat from this guy? So now this is where I have no idea how this works. So if I go to await, what does await do? Await blocks until one of the tasks have finished. Okay, I see. So what we need to do is so let's think. We need to set this as the session future, or rather what we need to set as the session future, we can wrap this in another async, I think, with IO. And this guy here, we need to check run session, I guess. And then the arguments would be self and select. Okay, this is actually fun. Let's try this. So run session that takes in self pointer to session, and then takes in the select, which is io.select of select union. So I guess we are going to need to declare this somewhere in here. Fine. Let's just assume that's okay. Right, so where were we? We were here. This guy here returns void. Let's just go for that. Right, so here what we are going to do is try, I'm not sure, so select.await. Yeah, and this guy captures some sort of item. So let's go for E. So this E here is the union we've just defined, and now we can switch on E and do, if it's heartbeat timer, we can call handle heartbeat. So with self and IO. And if it's session loop, we can do okay, we can do something here. We can do handle message handle message. Let's just go for this for now. Hold on a minute. So let's assume that we are going to get buffer or framed. Let's go for frame. This guy will take IO and frame and just run with that. So now that means that I need to change this guy to become effectively this guy. So hold on a minute. I'm going to do this. So now this guy wants just so let's do something like this .transport.tls client.reader. So we can get rid of these, and then this guy will capture. So this guy returns a framed message or an error. So I need to put that into here. So framed. So that should be under Binance. No, it should be under SBE, and I guess we need to import. No, it's under FIX transport, so that's fine. FIX transport framed message. Cool. And then this guy, of course, needs any error, and we'll see if this builds or not at all. But so what is the problem here? Has white space on its side. So while this guy expected statement found not sure what the problem is here. But okay, so this guy here, handle message should exist. So that would be handle message that will take in self session and IO item, and the frame, which would be just a framed message, I would assume. This would be under FIX transport. Yeah, sure. This guy will just return void, and for now, this should allow us to move forwards. So this guy wants the session, the IO, and the select. So we are going to need to pass the IO in here. Okay. Not sure what this is complaining about, but okay. So these guys, let's actually do something like self and IO. Same will go here. Just going to do discard self, discard IO, and probably not discard the frame. I'm just going to do something like, let's just dump the frame. So log.info or .debug here, got frame, and something like this. I don't care. And we can do frame.header.template ID for now. Okay. That does look okay. So this guy now is not used. Session loop is not used anymore, but we should be okay to move on. So I'm just trying to think about what's going to go wrong, other than just everything. But let's try to build. Okay, so 129. What is it? It's expecting a slice, but found a thingy of thingy. So this guy should become a buffer. So expected a pointer, but found a const pointer. So that's the select. I'm thinking. So expected type IO future of whatever, and found IO future of void. What? Run session? Where is run session? Okay, so this guy here now becomes just this. Okay, so 143 expected a pointer to const. What? Oh, because await might change the. Okay, so that means that this guy here needs to be passed like so, and that means that this guy here. Wait. This might be a bit of a problem here. This is stack created, so we are going to see problems. Let me just make a mental note of that. So what is the issue here? Expected type of void, but found error cancelled or void. Where? Oh, in the try? Oh, I see. So this guy here cannot. Well, why not though? So this guy could do this, and this guy could be changed to become so any error sort of or void. So why not do that? Right. So expected type found void error. So where is this? This is in. Okay, so I think the problem is we should probably define an error set. But you know what? I don't care. So any error will be our error set. Clear. fine. So expect optional type found main select union. What? I'm not sure what this problem is. Is any of these returning an error? No. So what's going on? So expect optional type, but found main session select union. I mean, yeah. Oh, I see. I see. So does that mean that we need to... Okay. So let's make this infinite and just do const. I guess selected is select.await, and this guy will need to be tried, and then here we can do selected dot whatever. Okay. Right, so switch on union with no attached enums. What is my guy going on about? Oh, I see. So I need to, yeah. Okay, that's my bad, I think. Right, so this guy here should now be happy with me. So 147, and that's here. So expected t, but found any error of t. How come? Frame. So frame is what? Frame is any error or frame. What? No. Oh, I see, because this guy here returns any error or frame. Right. Okay. That's fine. That's fine. So we could probably just go ahead and try this guy. Okay. We are getting there. So expected type void, but found error cancelled or void, and I have no idea where that is. So union init, that should be somewhere in the init of this guy, somewhere around here. So can I just have a bit more info about this? So f reference trace 8. So that's 131. So this guy, what does it return? Oh, it returns cancellable or void, and I just said that it could just be void. Okay, but the error message is lacking, but okay. So error dot cancelled or void, I think, is what they expect. Okay, fine. Can we please do this? Okay. Timer fired, got frame. Okay, well, it does work. It does work. Yeah, okay. I don't know what to think just yet about how this is done, but well, it is working. So I guess that's the main thing. So this guy here needs to become self-running, and Yeah, so now we need to do the message handling inline. So this guy here will go from here to here. Okay, I'm just going to rename all the frame to just frame. And we also need this guy. So at this point here, I'm not sure if it's interesting to create this message buffer on the heap every time this guy is created, or to just pass in a pointer from create here, which is long running, and we know that this guy here is single threaded. No, we don't know that. Yeah, so let's keep it this way. Let's keep it this way. That should be okay. So frame in here. This session loop should just be retired now. And if this works, okay, it was too easy. So 168. What is the issue here? So expected type void, but found what? Oh, I see. Because this guy was supposed to be void, but now it's not. So let's not assume that either. We can actually do this. We have set up things to be able to do that. So we should now just get the timer fired message and then get the handler message to the other things. Maybe. Are we blocked somewhere? This is not good. This is not good. Are we blocking this somewhere? So let's just add back our log debug. Okay, so we go into the message handler, but we never really do anything here. So hold on, let me just try this. Oops. Wait, what is going on? So from what I'm gathering, this switch here is blocked somehow for some reason. Not sure why this await is not re-triggering, because it should at least trigger on the heartbeats, right? So let's try something here. Instead of passing this, we are going to be passing so io.duration.from seconds, and I'm just going to do 1 second, right? Just so we can see every second that we get the timer fired message. And you can see that now it's not firing anymore. So there's clearly something wrong here with... okay, I see what the problem might be. This IO function here is just called once. Is that like a way to rearm this guy? Or is it just marked as done and then that's it? Put one cancelable. I guess that should be the problem then. It just runs this once and then it just dies. Okay, well that's sad. So let's try. We are going to need to wrap those. Message loop is something that takes self. Sure, just self, I guess. So that would be session and then returns something like this. And I guess, yeah, we could do the same here for a timer loop, which also should take, this guy is simple, so IO a duration, I guess. So that's IO duration, and the clock is fixed. So yeah. So this guy should also do this. This message loop will, while self run in, do something like return. Oh, I'm not sure how to go about this though. Because what I need to do is I need to in-queue back the next message to the queue used in the select. So what I need to do is get the queue and then just put an element on the queue and then wait on that. So I'm not sure how this how am I supposed to do this? This I need to test a few things. For the timer, I think that should be a bit easier, I believe. So because if I do sleep and I do IO duration and just awake. No. Oh, maybe I could wrap this into io.async. So that would be IO. This guy here, and then these guys. So something like this. So, and then we can do something like wait on this guy. That should rearm the timer loop. I actually have no idea how this, so let's just change this to timer loop. Takes in the same things, except this guy now goes. Let's see if this builds first. Member function expects one argument, but found 0, because await wants IO. IO. And I guess this guy wants, so I guess var sleep is this guy, and we return sleep.await IO. Yeah, of course, this guy needs this guy. No, still not working. It's still not working. So I need to make I need to research this a bit. Okay, I think I have a pretty good idea of how this should be done. Right, so what we need is, this would still need to be a session, yeah, sure, session future that is, no, this would go back to becoming a session loop. And what we are going to do is, so this function here, f1, let's call it, this will create the select in a loop, and then the select would just be this guy. Right, so just put this here, change this to while self dot run in, and do this guy in a loop, and then we just await on this. So this guy will be run session. I know that there's another run session somewhere here. Just call this 2. And this guy here will take just self, which would be this, and this guy of course will error or thingy, and of course here we also need IO, because why the hell not? Right, so here there's no that anymore. And now we should be doing this in a loop. So what we should be doing is something like this. Yeah, okay. Okay. Now I'm not sure if this is going to work first try, but we sure are going to try this. Okay, what is the issue here? So in 210, whoa, no, that's too far. That's too far. So expected type IO future of any error or whatever, and we found, oh, I see. So now this guy here is not a session. Wait, what? Oh, I see. Okay, so this guy here wants any error, not just the specific error set. So timer fired. Okay, so we are doing okay at this time. Okay, cool. This now is working. So can we go set our timer back to what was our timer for? Okay, so I guess we are also going to need to put that guy in here. So heartbeat interval, I guess we should call it. So IO duration. This also undefined for now. Self.heartbeat interval is options.heartbeat heartbeat interval. Right. So where was that used? Okay, there we go. So self.heartbeat interval, not internal, but interval. Cool. So let's try this again. This time we should see a heartbeat timer on a 5-second interval. Yeah, that looks about right. That looks about right. So, okay, let's now actually handle the timer. So message loop, this goes. Timer loop should also go. And, oh, wait, what is going on? Yeah, timer loop should go. Why is this? Yeah, okay, sleep. No, that would be IO sleep. Okay. All right. You know what? Happy with that. I'm pretty happy with how that turned out. So let's now try to handle. So I'm just going to get rid of this guy, get rid of this guy also, and now we should probably have added timestamps to the message prints, because the TCP receive thing here is not giving us much info. Yeah, there's a problem. I think there is a bit of an issue on this guy. So log.debug, and I'm going to just dump the frame, which is this guy, frame. Okay. I mean, it looks like it's working. So, okay, you know what? We are going to move. No, but before that, I'm going to also add binance dot reject codec dot template ID, and I just want to get any error messages out of the way before we move. I think we've already gotten this guy, so I guess we could just put this into this guy. Right, so this is, we decode the thing, we dump it, and then we just return the error. So can we check this? Okay, there's a problem with this. I think I'm seeing a lot of timer fired. I am seeing a lot of timer fired. Is this the issue? Is it the clock? So the first one comes after 5 seconds. And then there are 3 in the next 5 seconds. So I'm not sure why that is. So yeah, I'm not sure. I believe the reason why we are getting multiple of those is because we are I think we can do something like defer select dot cancel discards. What does this do? What does this guy do? So requests cancellation on all and then blocks until they all finish and all return values are discarded. Okay, and I think we should just also discard anything that hasn't finished yet, because I think that's what's happening here. We schedule both the loop and the timer. It so happens that the loop ends first, but the timer is still scheduled, so we still get the timer fire, and that's how we get multiple timer fires. So let's see if this works now. Okay, so that's the first timer fired. Then we handle the message. Okay, so now the timer fired is doing okay, and then we send back another message. Okay, that looks a lot like what I expect. So that being said, now we do have some sort of working-ish thing. What I'm just going to need to do very quickly is I'm going to implement this heartbeat logic, and this is probably going to be a time lapse. So see you in a bit. Okay, so we are back. Handle heartbeat, very simple logic. We check that we have already sent a heartbeat. If we did, then we check the duration. If it's above, I guess should be or equal, but yeah, let's leave it. If it's above the last time we've sent plus the interval, we call this function here, send heartbeat, that basically just serializes a message to the wire. Same for if we received a heartbeat from the server, we check the last time we've received it. If we received it too far in the past, so beyond the heartbeat interval we've agreed on, if we already sent a test request to the server, we error out, because that means that there's something weird with the connection. It's probably broken. Otherwise, or we are a slow consumer and we haven't seen the heartbeat, but that's a bigger problem. Otherwise, we create an ID, a request ID from just the timestamp, 2 nanoseconds, put that into this array here as a buffer, and we send test request sent to true, and then we send test request to the wire. So pretty much the same thing again. And on the handle message side, there are a few changes here. So first we log the timestamp for the heartbeat reception, and then if we had sent a test request, we try to get the request ID from the message we got, and we try to compare that to the ID we are expecting, and we set this to false if it matches. It means that we got our answer back. Otherwise, I think this guy here we could actually use send heartbeat. So this needs IO message buffer, and we could probably add the ID to this, and ID here could be test request decoder dot test request ID. Of course, with a try. And this is, wait, hold on. Okay, so this means that now I could add in an ID that is an option of a const u8. Yeah, on this guy here, this null becomes ID. Okay, does sound okay to me. But that means that we also need to change this guy. So, and is that the only thing we need to change? I think so. So let's build this and see if it works. Okay. Yes, of course, I forgot to add the length, at least to initialize this guy. So this, and there's also something I'm going to do here. I'm going to drop this and this. And I am going to actually do IO timestamp.min 0. Okay, so IO timestamp 0. So that means that in here I could get rid of this guy. So this becomes const last heartbeat. Timestamp is this guy. Okay. Same goes for this guy. So let me just rename this to transmitted heartbeat. Okay. Then this becomes last received heartbeat timestamp is this guy. There we go. And we can do just this, I think. We can get rid of this. And now this guy wants to be received heartbeat. Okay. That should all be good. So we should send a heartbeat as soon as the timer ticks. And we sent a test request with it, so that's fine. But we did not get the times. Wait, what? Oh, huh. I think that at this point here, we should also set last. So transmitted. No, wait. So test request. Now this is problematic because we would like to wait at least until the first heartbeat is sent, or rather until we first establish the connection with the server to do this check again. That's problematic because we do this check twice in a row and it basically fails the second time. Wait, hold on a minute. I'm just going to take a look at this guy. So this guy we've set to be 5 seconds, right? Yeah. And this guy is flushed. This guy is flushed. And we are not receiving a heartbeat here. Oh, I think I know why that is. Because we have sent the test request as soon as we could, and we just received the heartbeat back from the normal heartbeat back that didn't have our test request in it. Well, that's kind of a bummer, I would say. But I guess we could, for now, just do something like let's just double it, just to see if this is better or not. Okay, so do we have a problem here? So let's log debug got back test request from sure, just got back test request. And let's just do this. I don't think I need to print the message we got back. We're not getting back our thing from the server. That's kind of sad. Let me actually check that this is not related to the equal test we do here. So let me just move this to here and do this versus this. And this guy would be test request ID, and this one would be expected. Okay, let's try this again. Okay. Wait, hold on a minute. Am I seeing things, or is this not working? 2 nanoseconds, 2 microseconds. Sure. And let me also just try to debug. Test request ID is this, which is ID like this. Okay, so we do have a problem. We are not getting back our test ID, test request ID. Is it at least sent? Like, is it serialized in the message body? Let's take a look. TLS client dot writer dot buffered, and let's see. So it does look like, so we do have 16 items, and this looks like 16 to me. And then we do have, so 1776. So it does look like we do send the correct stuff. So what is going on? Yeah, okay, so the problem, as always, is me. So this guy needs to become frame.body so that we can actually read the freaking message from the freaking body. And now we should, in theory, hopefully, okay, hold on a minute. So we deserialized this from the thing, but the expected was not correct. What? Self dot pinned in this request ID. Let me just print the whole thing. Let's see. Well, so what is going on? Have I never set the length? I have never set the length, did I? Okay. Okay, let me just check this. I never set the length. Cool. Very nice. So self.pending test ID length is id.length. Okay. So all is good. All is fine. So what did I? Yep. So this is expected, and now we should see a strict equality. And we could probably remove this hack with here. Yeah, cool. So we got back what we expect, and now we can just move on to rejected. Hold on. First of all, why is our reject message weird? So that's something we can do. Hope we can do that. So if I just redo this, what is going on? Received error. Hold on, can I do something like this, or else this guy? So this should be just a const u8. So why is this still printing that thing? So I'm just going to interrupt this and try again. Why? What is this doing here? I'm just going to remove this. This should be a compile error, of course. So now if I add or else something like this should be okay. And now I should be able to do this. I have no idea what this is doing. What is going on? Hold on, is there like a receive error? Oh shit, received error. Okay, so we do have two of those. Okay. Oh, right, fine. So we can do this, or else no bytes, like so. Cool. Okay, fine. So let's interrupt this again and try. Sender comp ID is currently in use. Okay, cool. Very nice. Let's try this again. This time we are looking for the heartbeat stuff. Cool. So we sent a test request. We got back a heartbeat. And why did we send a test request again? Is the server too slow? Is that why we're sending back heartbeats or test requests? Hold on. So this guy, we are recording the last time we've received the heartbeat. Yeah, okay. And wait, what is going on here? Should probably get rid of all of this now. Yeah. Okay. Right. So that should be it. And now to wrap this up, we are going to. So this one is working on the transmitted heartbeat. We send a new one, and oh, okay. Hold on a minute. We send a new heartbeat, but we then need to know that we've sent a new heartbeat, don't we? So last transmitted heartbeat timestamp should be now. Okay. That should do it, I think. There we go. So now we just send back heartbeats on a schedule, but we still do quite a lot of these guys. So does that mean that the server is not getting back to us on time with their heartbeats? Yeah, I'm not sure. I'm not sure. So these are microseconds, I think. So that means that this here is the seconds. These are microseconds, right? Yeah. So that's micro, that's milli. So that's the second part. The one is the seconds part. And yeah, so here we have 86, 91, that's 5 seconds. And then 97, that's slightly more. But it's fine, it's okay. I'm not sure why we need to send that many messages. From what we've seen, the server did send us enough heartbeats. But let's just go for that it's okay for now. So I'm just going to remove all of these and this. Same for this. And I'm just going to also go here and put the heartbeat back to a healthy 30 seconds. Right. So now what I'm going to do next, just to end on a high note, is I'm going to add a handler here. So hold on. First of all, administrative messages. So we have log on, log out, news, and resend requests that are not supported. So we don't have to support them. News are meh, and log out is probably important to handle. So let's just add binance.logout codec.template ID. If we receive a logout message, we are just going to do self.runIn is false, and just going to do something like logged out from server. And probably this can be worn. Something like this, which is okay. So now let's actually try to end on a high note. So let's add, instead of doing this received and handled message, what we are going to do is, so I am thinking, and I think we can just leave this be. But for now, we need to also allow us to send outside messages, so outbound messages to the server. So public function request, and these will be typed. So request instrument list. This will be self session. Not sure if it's going to need to be mutable or not, but for now, let's move. So here, fairly simple. So var instrument list encoder. This will be Binance instrument list request codec, and we are going to encode into some sort of buffer. So can we please get a buffer? Okay. Right. So this guy goes into message buffer, and we do set instrument list request type. So all instruments, sure, give me all of them. And instrument list set request ID. Is this? Are we forced to set this? Can I find the instrument? Where are they? Where are the instruments? Instrument request. So the ID of this request. So I guess I can just do insters or inster for now. And what's the other thing? Symbol. So symbol is not required, so we can just move. Right, and here we can go ahead and do self dot TLS client, or yeah, I guess we can just go ahead and hold on a minute. We can just go ahead and do this. That's fairly okay. And that means that we also need this guy to become or to be put here. And we also need this guy, of course. Okay, so this guy now becomes instrument list encoder dot encoded body, and now we are going to send the request to the server. So here, I actually want to send this just before this guy awaits. So I'm going to do session dot request instrument list. Does this fail at some point? Did we try something here? Yes, we did. So this guy here needs to also propagate the error. And it needed IO, of course. Yeah, we do need IO. Right, so what's error union is ignored? Where's that? All instruments, of course, this guy and this guy. Oops, not true, dry. Missing message IDs. Okay, of course. I need to put these in order, or rather in the order they appear in this XML here, list request. So request type first, then request, then a symbol. So that was, okay, so the symbol is missing, of course. So instrument list encoder dot set symbol to null. Whoops, there we go. That should, in theory, what? What is going on? Oh, of course. Instrument list codec dot heartbeat thingy. So I think I don't even need to do this anymore. Write failed. Okay, I see. So that's very good news. That's very good news. It's very good news because this guy now will fill up fairly quickly. So let's go undo. Where is our session thing? So this should be somewhere in handle message or wait, hold on a minute. So this guy, I'm not sure what the problem is. So does this guy fail? So hold on, there's this died thing here. So on connect, we failed. No, there's no way. No, so that means that there's something that happened between these two things. So what is going on here? So if I just remove this disconnect here, it's going to leak, but it's fine. Okay, so this guy is still not happy with what it's doing. So connect goes through, and then this request instrument body here should also go through. Of course, there's one problem here is that this transport here is not synchronized at all. So we could be right into it while we are doing something else. So that's problematic, but we are going to assume that that's not the problem that we have currently. I'm just going to do this. Yeah, sure. Let's just do something like, can we please? All right. So yeah, as I suspected, this buffer here is too small to have this writer write to it. And this guy would just try to brute force the whole schema, which is not possible at this point. So what I'm going to do is I'm going to get rid of this, and instead I'm going to go back to the trusty, I don't have it anymore, that's too bad, trusty stat out writer. So this guy is io.file.stat.out.writer. Of course, this guy needs a stat out buffer so that we can provide. So this guy here, I'm just going to put in 512 also, although it's going to be a bit small, but we are going to need to flush it anyway. So yeah. So this guy undefined, and then this guy will be set out writer. Same for this, stud out writer. Two arguments. I guess there's an IO that's missing here. And of course, this should be called interface. And same for this, I believe. Okay. Well, that's very good news. I think we are going to end on this high note, but what we have here is, let me just try to look for something that's that we can understand. So these are the data for BTC USD, and we can see that there's a min price increment, and I guess this, yeah, so we have an exponent here, so that's 10 to the minus 8 times this guy here. So we have price ranges, we have quantity ranges, we have the trade volume, start price range. Yeah, so we have currency symbol. We do have info about the instrument. So if we look for ETH or something like this, no, okay. So not sure why there's no, is it like ETH BTC or something? Yeah, okay. I'm not very knowledgeable about crypto, but to me that looks like something useful or usable. So yeah, we are going to end on this high note. So after all that fussing about, we did get the instrument info from Binance and handled the administrative messages. By the way, I hope you've liked this. I'll see you next time. Fucking hell.